Welcome viewers, in this video we'll see the solved problem in the resonance circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Resonance circuit solved problem 1. First we will see the statement of the problem. A series RLC circuit with R equal to 10 ohm and L equal to 1 millihenry and C equal to 1000 picofarad is connected across a sinusoidal source of 20 voltage with variable frequency. So RLC is connected in series across the sinusoidal source of 20 voltage. The question is, compute the resonant frequency of the circuit. Find the Q factor of the circuit at resonant frequency. Determine the half power frequencies. These three topics we need to identify. So the given data, R equal to 10 ohm, L equal to 1 millihenry, that is 1 into 10 to the power minus 3 henry, C equal to 1000 picofarad, that is 1000 into 10 to the power minus 2 minus 12 farad, and the voltage is 20 voltage. Now we'll identify the topics one by one. First one is the resonant frequency. First we need to find the resonant frequency. So the formula for resonant frequency, F naught equal to 1 divided by 2 pi square root of LC. Now substitute the value 1 divided by 2 into pi into square root of L is 1 into 10 to the power minus 3. C is 1000 into 10 to the power minus 12. So while simplifying we got this 1,59,155 Hz. So this is a resonant frequency. And we'll go to the Q factor, quality factor. The formula is 1 by R into square root of L by C. So that is equal to R value is 10, L is 1 into 10 to the power minus 3, C is 10 to the power minus 1000 into 10 to the power minus 12. So while simplifying we got 100. So the quality factor is 100. Now we'll find the half power frequency, F1 and F2. Two half power frequencies we'll find one by one. F1 equal to F naught minus R divided by 4 pi into L. So that is equal to 1,59,155. So this is the F naught value minus R value is 10 divided by 4 into pi into 1 into 10 to the power minus 3. So this value is 1,58,359 Hz. F1, lower half hour frequency F1 value identified. Now we'll see the upper half hour frequency F2 equal to F naught plus R divided by 4 pi L. Here F naught minus, here F naught plus. So 1,59,155 plus R value is 10 divided by 4 into pi into L value is 1 into 10 to the power minus 3. So here 1,59,951 Hz. So now we got the value of F2 also, the upper half power frequency. So in this we discussed the solved problem in resonance circuit. We calculated the resonant frequency, quality factor, half power frequency, upper half power frequency and lower half power frequency. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers, in this video we'll see the solved problem based on the resonance circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Resonance circuit solved problem number 2. First we'll see the statement of the problem. A series RLC circuit with quality factor Q equal to 250 is resonant at 1.5 megahertz. Find the frequency at half power point and also bandwidth. So the quality factor is given, Q equal to 250. Resonant frequency is given, F naught equal to 1.5 megahertz, that is equal to 1.5 into 10 to the power 6 hertz. We need to find the bandwidth as well as the half power frequency at the half hour points. First we will find the bandwidth. Bandwidth we'll find from the quality factor. quality factor is given. From that we can easily find the bandwidth. Quality factor Q equal to F naught divided by F2 minus F1. Right. From that you interchange these two parameters. F2 minus F1 equal to F naught divided by Q. This F2 minus F1 is nothing but a bandwidth. Bandwidth is nothing but difference between the upper half hour frequency and lower half hour frequency. So F naught value is given 1.5 into 10 to the power 6. Q is given 250. So by simplifying we got 6000 Hz. So F2 minus F1 equal to 6000 Hz. So that is nothing but bandwidth. Bandwidth equal to F2 minus F1 equal to 6000 Hz. Now we'll see the frequency at the half hour. Frequency of the half hour means F1 into F2. That is the frequency at the half hour. So we know the formula F1 into F2 equal to F naught square. Formula is available. F naught value is given 1.5 megahertz. So 1.5 into 10 to the power 6 into square. So while square it got 2.25 into 10 to the power 12. So the frequency at the half hour is 2.25 into 10 to the power 12. So in this video we calculated the bandwidth and frequency at the half hour. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the solved problem based on the resonance circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic. You see the statement of the problem. For the parallel network shown in diagram, determine the value of resistance R for the resonance. We need to find the resistance value at the resonant condition. So let us consider this parallel circuit. Applied voltage is E. In the first branch, resistor and inductor is connected, 10 ohm and J10 ohm. In second branch, the resistor, variable resistor with capacitor is connected. We need to find this R value. Capacitor value is minus 2J. So the given is that it is a resonant condition. What is the resonant condition? The reactive part is 0 at the resonant condition. So based on that, first we will find the admittance, total admittance. Admittance is nothing but the reciprocal of conductance. Reciprocal of the conductance. Y equal to Y1 plus Y2. So this is the reciprocal of the impedance. So admittance is the impedance, not a conductance. The reciprocal of admittance is the impedance. So 1 divided by Z1 plus 1 divided by Z2. Z1 refers first branch, Z2 refers the second branch. So Y is total admittance is calculated in terms of impedance, because the impedance we can easily type. So the impedance in the first circuit is 10 plus J10. 10 plus J10. The second circuit is R minus 2J. Right? So Y equal to, we calculated the impedance in first branch and second branch. Now we need to solve this, the impedance value. We need to simplify this impedance value, and we have to equate the reactive part. Reactive part equal to 0, so that we will be able to find the value of R. That is the condition given. At resonant, the reactive part is 0. Now we will go for the simplification. So here the J term available in the denominator. So in order to bring in numerator, it is multiplied and divided by the complex conjugate. 10 minus J10. Here 10 plus J10. So multiplied and divided by 10 minus J10. Similarly here R minus 2J is there. So multiplied and divided by R plus 2J. Right. Now we'll simplify this. So 10 minus J10 divided by, so this is nothing but A plus B into A minus B. A is 10, B is J10. What is that? A plus B into A minus B, A square minus B square. So 10 square minus J10 square. Similarly here R plus 2J, here A is R, B is 2J. Right? So R square minus, this one is minus, R square minus 2J square. A square minus B square, here also A square minus B square. So we'll go for further. 10 square is 100, J10 the whole square is J square into 100. Similarly here R square, 2J square is 4J square. We know that J square value is minus 1. Here also j square value is substituted minus 1. Right, minus into minus it become plus. Right, minus into minus it become plus 100. Minus 4 into minus 1 become plus 4. So finally what we got, 10 plus minus j10 divided by 200. 100 plus 100, 200 divided by r plus 2j divided by r square plus 4. Now we'll split the terms. Here the two terms available, it is split at 10 divided by 200 minus j10 divided by 200, r divided by r square plus 4, 2j plus divided by r square plus 4. Now these two terms are real terms. These are all imaginary terms. Real part, reactive part. So these two terms are written separately. 10 divided by 200 is 0.05, 0.05 plus r square, r divided by r square plus 4. Here j is taken common. First this term is written because here plus is there, here minus is there. So 2 divided by r square plus 4 minus 10 divided by 200 is 1 by 20. So this is now the real term. This is reactive term. So based on the resonance condition given, this reactive part is 0. Now we'll go for the further simplification. So at resonance, the reactive part of y is 0. 2 divided by r square plus 4 minus 1 by 20 equal to 0. That is the condition given in the problem. So we are equating the reactive part equal to 0. Bring this minus 1 by 20 that side. So it become plus 1 by 20. Now cross multiply this. 2 into 20, here 1 into r square plus 4. So 2 into 20 is 40 equal to r square plus 4. Bring this 4 this side. So it become minus 4. 40 minus 4 equal to r square. 40 minus 4 is 36 equal to r square. So square root take the square root on both sides. So square root of 36 is 6. R square is r. That is r value equal to 6 ohm. Right. So based on the given condition, resonance is given and resonance reactive part is 0. We equated the reactive part is 0. After simplification, we got the value of resistance. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we'll see the solved problem based on the resonance circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. We'll see the statement of the problem. A coil of 20 ohm resonance have an inductance of 0.2 Henry and connected in parallel with a condenser of 100 microfarad capacitor. So one coil with 20 ohm resistor and 0.2 Henry is connected in parallel with the capacitor 100 microfarad. Calculate the frequency at which the circuit acts as a non-inductive resistance of R ohm. Find also the value of the resistance. So R1 given as 20 ohm. We need to find the R value when it is act as a non-inductive resistance. So we'll take this is the R1. L is 0.2 Henry. C is 100 microfarad. That is 100 into 10 to the power minus 6 farad. Now we'll see the diagram. So this is the given diagram. The applied voltage is E. This is a non-inductive. It's a coil with the inductance L and resistor R that is connected in parallel with the capacitor. This R value is R1 value is already given. Now we need to find the R value at the frequency at which act as a non-inductive resistance. The circuit is given to be acting as non-inductive resistance. This means that the circuit is at resonance. The meaning of non-inductive resistance is resonance. That is, inductive reactance and capacitive reactance are equal, got cancelled. The circuit is act as only resistance under resonant condition. So the resonant frequency is F0 equal to 1 divided by 2 pi square root of 1 divided by LC minus R1 square divided by L square. This is the resonant frequency. We'll take this equation number 1. So at resonance condition, Y equal to R1 divided by R1 square plus XL square. You take equation number 2. This is the resonant condition. Now substitute the values. In equation 1, we will substitute the value and find the resonant frequency. 1 divided by 2 into pi square root of 1 divided by L. L is 0.2 into C value. C is 100 into 10 to the power minus 6 minus R1 square 20 ohm divided by L square 0.2 square. So while simplifying, we got 31.83 Hz. The resonant frequency is 31.83 Hz. So the condition given is non-inductive resistant. So that means the resonance. That is the meaning is the circuit at resonance. Now we calculated the resonant frequency. Now we'll go for the further parameters. So one more formula, the admittance Y equal to R1 divided by R1 square plus XL square. This is under the resonant condition. So Z equal to 1 by Y, that is equal to R. Under the resonant condition, the impedance is only resistance value. That Z equal to R. Z is nothing but 1 by Y. This admittance and impedance both are inverse, both are reciprocal. So that meaning is Z equal to R equal to 1 by Y. Y value is already available. 1 by Y means reciprocal. R1 square plus XL square divided by R1. Right? Y is there, so that we can write 1 by Y. Now we'll substitute all the values. R is 20, 20 square R1 plus XL square is nothing but 2 pi FL divided by R1 is 20. So this FL value also substituted. 2 into pi into F is 31.83, what we calculated, resonant frequency. Inductance is 0.2 divided by 20. So while simplifying, we got 100 ohm. So this is nothing but impedance. At resonant condition, impedance is nothing but only resistance, R value. That is equal to 100 ohm. So finally, we calculated the resonant condition. Under resonant condition, the resistance value is 100 ohm. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we will see the solved problem based on the resonance circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the problem. A current source is applied to the parallel combination of R, L and C, where the R value is 10 ohm, L equal to 1 Henry and C equal to 1 microfarad. So parallel RLC is available. In that, current source is applied. The values are given. First one, we need to find the compute the resonant frequency. Second one, calculate the value of bandwidth. Third one, quality factor. Fourth one, compute the lower and upper frequency points of the bandwidth. Now we'll see the diagram. So this is the parallel RLC circuit. R, L, C all are connected in parallel. 3 branches. Current source is applied. First we will find the resonant frequency. Resonant frequency omega naught, the formula is 1 divided by square root of LC. So omega naught equal to 1 divided by L is nothing but 1 Henry. C is 1 microfarad. So 1 into 10 to the power minus 6. So while simplifying, what we got, 1000 radian per second. So the resonant frequency is 1000 radian per second. Now we'll go to the second parameter. So next we will find the quality factor Q. Q is nothing but 1 divided by omega naught into R into C. So that is equal to 1 divided by omega naught, what we calculated is 1000 into R value is 10 ohm. C is 1 microfarad. So this 10 to the power minus 6. While simplifying, what we got, 100. So the quality factor is 100. Next, the third one, we'll find the bandwidth. Del omega is nothing but omega naught divided by Q. Omega naught, what we calculated, 1000. Q, what we calculated, 100. 1000 by 100, it is 10 radian per second. So the bandwidth is 10 radian per second. Now we'll see the lower frequency point and upper frequency point, omega 1 and omega 2. Omega 1 equal to omega naught into square root of 1 minus 1 divided by 2 Q square. It's a formula. Omega naught is 1000 into square root of 1 minus 1 divided by 2 into quality factor what we calculated is 100 square. So while simplifying we got 999.975 radian per second. It's a lower frequency point. Similarly, we'll see the upper frequency point omega 2. The same formula here, omega naught divided by, here omega naught multiplied, divided by square root of 1 minus 1 divided by q square. Omega naught what we calculated 1000 divided by square root of 1 minus 1 divided by 2 into q square, 100 square, quality factor is 100 square. So while simplifying we got 1000.025 radian per second. So we calculated all the 4 parameters for this given RLC parallel circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the solved problem based on the resonant circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. See the statement of the problem. Determine the value of the capacitor C in order that the circuit in the diagram is at resonant at 6366 Hz. We need to find the capacitor value. Consider this circuit, the applied voltage E and frequency. In one branch, resistor and inductor is connected, 10 ohm, J5 ohm. In another branch, resistor and capacitor is connected, 12.5 ohm and capacitor. This C value we need to find. The condition given is the circuit is at the resonant condition. The resonant frequency also given 6366 Hz. Now we'll find the total admittance. The resonant condition means the reactive parts of admittance is 0. A plus JB means B equal to 0. That is the condition for resonance. That is inductive reactance equal to capacitive reactance, so got cancelled. Only resistance will be there. The reactive part is 0. So in order to go further, we will find the total admittance. In that we are going to equate the reactive part equal to 0 so that we can be able to find the C value. So the total admittance equal to Y1 plus Y2. Y1 means branch 1, Y2 is second branch. In the first branch we have resistor and inductor. Second branch resistor and capacitor. This admittance is nothing but reciprocal of the impedance. Both are reciprocal, impedance and admittance. So it can be written as 1 divided by Z1 plus 1 divided by Z2. Z1 is nothing but resistor plus inductor, 10 plus J5. Z2 is second branch, resistor and capacitor, 12.5 minus JXC, right? So this C value not available, so it is written JXC, right? Now we can go for the further simplification. Now this is the total impedance. The J is available in the denominator. In order to bring into numerator, it is multiplied and divided by the complex conjugate, so that will brought the J term in the numerator. So the complex conjugate of 10 plus J5 is 10 minus J5. So it is multiplied and divided. Similarly, 12.5 minus JXC, complex conjugate is 12.5 plus JXC, multiplied and divided. So here, while simplifying, this 10 minus J5 is written. So this term is nothing but A plus B into A minus B. A is 10, B is J5. A plus B into A minus B is nothing but A square minus B square. A is 10, 10 square minus B is J5, J5 square. Similarly, this term 12.5 Jx is written here. This is also A minus B into A plus B. It's nothing but A square minus B square. A is 12.5, B is Jxc. Right. Now we'll square the term. 10 square is 100. J5 square is 25 J square. 12.5 square is 156.25 minus J square Xc square. We know that J square value is minus 1. Here also J square value is substituted minus 1. So minus 25 into minus 1, it become plus. So here also minus into minus become plus. Right? The term become the plus. So it is written 100 plus 25, 156.25 plus Jxc square. Right. Now so this 100 minus 25 is 125. Now we'll split the terms. 10 divided by 125, right? Minus j into 5 divided by 25. These terms are splitted. Similarly, 125 divided by this term plus jxc divided by this term. Now we see these two are real terms. The term contained j is the imaginary term, that is the reactive part. Right. Now these two terms are written separately. That is simplified. 10 divided by 125 is 0.08 minus 5 by 125 plus these two terms are written. Now we'll combine these two terms. First term and third term, that is the real term. Second and fourth is the imaginary term. Now we'll combine. Now these two terms are combined together. These two are the real term. This is the imaginary term. So the condition given is resonance. Under resonance, the reactive part of Y is equal to 0. That is, this term is equal to 0. That is, capacitive inductance and reactive inductive reactance are got cancelled. So that this reactant part is 0. So that is the condition given in the problem. So Xc divided by 156.25 plus Xc square minus 5 by 120 equal to 0. Bring this term that side, so it become plus 5 by 125. So Xc divided by this term, so 5 divided by 125 is 1 by 25. This goes with the 25 times. Now we'll cross multiply this. We'll cross multiply the terms for the further simplification. So it become 25 Xc equal to this term 156.25 plus Xc square. Bring this 25 Xc that side so that it become minus 25 Xc. So that is equal to 0. So it can be written as Xc square minus 25 Xc plus 156.25 Xc equal to 0. This is nothing but a quadratic equation. So this can be written as Xc minus 12.5 the whole square. A minus b the whole square is a square plus b square minus 2 into a into b. Based on the formula we can write. So x minus 12.5 equal to 0. So x equal to 12.5. So from the given condition we got the xc value. But what we need is the capacitor value. Capacitor value is needed. So xc is the one more formula 1 divided by 2 pi f naught c. So here what we need is c. So interchange this term. Bring this term this side and bring the xc that side in the denominator. So c equal to 1 divided by 2 pi f naught into xc. So 1 divided by 2 into pi into this frequency is given, resonant frequency 6366 into 12.5. What we calculated xc is 12.5. So while simplifying we got 2 into 10 to the power minus 6 farad. That is nothing but 2 microfarad. So finally we calculated the capacitor value under the resonant condition by equating the impedance, admittance term, reactive part of admittance equated to 0, so that we got xc. From xc we calculated the c value. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we'll see the solved problem based on the resonant circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the statement. A coil of resistance 40 ohm and inductance 0.75 Henry form a part of series circuit for which the resonant frequency is 55 cycles per second. R and L is connected in series. For that the resonant frequency is given. If the supply voltage is 250 voltage 50 cycles per second, find the first one is line current, power factor and voltage across the coil. So the given data R equal to 40 ohm, L equal to 0.75 Henry, F naught equal to 55 cycles per second, resonant frequency. The supply frequency 50 cycles per second, applied voltage is 250 voltage. Now from this given resonant frequency, we know the formula F naught equal to 1 divided by 2 pi square root of LC. Square on both the sides, so F naught square equal to 1 divided by 2 pi square is 4 pi square. Square root of LC is LC. Right. Now from this we can able to find the C value. C value is not given. So we can able to find the capacitance value. So see this R and L is given but C value not given. So bring this C this side and F naught square that side in the denominator. So C equal to 1 divided by 4 pi square F naught square L. So all these values are available. 1 divided by 4 into pi square. F naught is 55. 55 square. L value is 0.75. So from that we are able to, by simplifying this, we can find the C value. 11.16 into 10 to the power minus 6 farad. So the C value is available. Now we'll be able to find the XL and XC. Inductive reactance and capacitive reactance. We know that XL equal to 2 pi FL. So 2 into pi into F is 50. Supply frequency 50 into L is 0.75. It's not 7.5. Is 0.75. So while simplifying we will get 235.6 ohm. The inductive reactance. Similarly, capacitive reactance Xc equal to 1 divided by 2 pi Fc. That is 1 divided by 2 into pi into supply frequency 50. The capacitance what we calculated 11.6 into 10 to the power minus 6. So while simplifying we will get 285.2 ohm. Right. So from this XL and XC we can able to find the impedance of the circuit. Impedance Z equal to square root of R square plus XL minus XC the whole square. It's a general formula. R value given 40 square. XL what we calculated 256.6. XC is 285.2. 235.6 minus 285.2 the whole square. So while simplifying we got 63.72 ohm capacitive. Right, it is coming under because of this value is a capacitive. So the impedance value we calculated. So from the resonant frequency first we calculated the capacitor value, then XL, XC, finally impedance. So from this value we can find the required data one by one. The first one is the line current. We need to find the line current. Line current, the magnitude of I equal to magnitude of E divided by magnitude of Z. Right? All are magnitude. So the supply voltage is 250. Z what we calculated 63.72. So while simplifying we got 3.92 amperes. Right? The line voltage, the line current is calculated as 3.92 ampere. Similarly we can able to find the power factor. Cos pi equal to R divided by Z. R is 40, Z is 63.72. So it is 0.628 leading. Power factor is leading. Next we need to find the voltage across the coil. So first we will find the impedance of the coil, then we will go for the voltage across the coil. Z coil, impedance of the coil equal to R square plus XL square. That is equal to square root of 40 square plus 235.6 square. So what we already calculated. So the Z coil is 239 ohm. So from by using this we can able to find the voltage across the coil. E coil, voltage across the coil equal to magnitude of I into magnitude of impedance of the coil. So I is already calculated 3.92 into impedance of the coil is 239 what we calculated. So by multiplying these two we got 937 voltage. So finally we calculated the voltage across the coil also. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers, in this video we will see the solved problem based on the resonance circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. You see the statement of the problem. A constant voltage at a frequency of 1 megahertz is applied to an inductor in series with a variable capacitor. When the capacitor is set to 500 picofarad, the current has the maximum value, while it is reduced to 1/2 when the capacitor is 600 picofarad. So the 1 megahertz frequency is given, inductor and capacitor connected in series, 500 picofarad is the capacitor value. When at the time the current is maximum, the current become 1/2 reduced to 1/2 when the capacitor value is 600 picofarad. For this, we need to find the resistance value, inductance value, Q factor of the inductor. So the given thing is F equal to 1 megahertz. That is 1 into 10 to the power 6 hertz. C equal to 500 picofarad. That is 500 into 10 to the power minus 12 farad. Right. So the F is given. So F equal to 1 divided by 2 pi root of LC by square on the both the side. The C value is given, L value is not given, so that we are able to find the L value from this capacity, from this frequency formula. A square on both the side, F square equal to 2 pi the whole square into LC. Square root of LC, where square it become LC. So F square equal to 1 divided by 4 pi square L into C. What we need is L. So bring the L this side and F square that side. So that L equal to 1 divided by 4 pi square C into F square. Now we can substitute all the values. 1 divided by 4 into pi square, C value is 500 picofarad, 500 into 10 to the power minus 12. And F value is 1 into 10 to the power 6 to the whole square, F square value, so whole square. So by simplifying, what we got, 0.0507 into 10 to the power minus 3 Henry. Right, the L value is calculated. Now we'll go for the next parameter. Let R be the resistance and E be the applied voltage for this given circuit. So at resonance, current I equal to E divided by R. So given that 600 picofarad, the current is reduced to half of the current at resonance. So already 500 picofarad, when it is 600 picofarad, the current reduced to 1.5. So for this case, let Z be the impedance when the current is half at the resonance. Therefore, E divided by Z equal to I divided by 2. So that is equal to 1 by 2 E divided by R. So that is equal to E divided by 2R. Right. So what is the formula here? This basic formula is I equal to E divided by R. So at this condition, I become half of the current become half. So I by 2. So that is equal to 1 by 2 E into R. Right. So this E, the Z can be written as R. So it is E divided by 2R. So this both are same. Z equal to 2R. So in this case, Z equal to 2R. Right. So E by Z equal to I by 2. That's a condition given. But I can be written as E by R. So based on this formula. So this I is replaced by E by R. So that E divided by 2R. So the impedance equal to 2 times of R. So that is the condition we got from this value. At 600 picofarad, current is half at the resonance, right? So I equal to E by R at the resonant condition. At this, E divided by Z equal to I divided by 2, half of the current. So this I is replaced by E by R because it is resonance, under resonance. So that by comparing this first and last step, Z equal to 2R, right? Now we'll go for the further simplification. Z equal to 2R by square on both the side, Z square equal to 4R square. We know that R square plus XL minus XC whole square equal to 4R square. That is Z. The basic formula is Z equal to Z square equal to R square plus XL minus XC the whole square. Based on that it is written. Bring this R square that side, so it become minus R square. So 4R square minus R square is 3R square. So XL minus XC the whole square equal to 3R square. Will take equation number 1. Now we'll find the XC and XL value. Capacitive reactance and inductive reactance. We know that XC equal to 1 divided by 2 pi F into C. 1 divided by 2 into pi into F value is 1 into 10 to the power 6. 1 megahertz. C value is 600 picofarad. 600 into 10 to the power minus 12. At this condition, the value is 600. So by simplifying, we got 265.3 ohm XC value. Similarly, XL equal to 2 pi F into L. So 2 into pi into F is 1 into 10 to the power 6. L value is 0.0507 into 10 to the power minus 3. We already calculated. So by simplifying, we got 318.6 ohm. So now calculated XL and XC. Right. From equation 1, XL minus XC the whole square equal to 3R square. Right. Bring the R in the denominator, this side. So XL minus XC the whole square divided by 3 equal to R square. Now take the square root on both the side. So R equal to XL minus XC, here square is there, over it become XL minus XC divided by root 3. So R equal to XL minus XC divided by root 3. So XL we calculated 318.6 minus XC is 265.3 divided by root 3. So while simplifying, we got R equal to 30.8 ohm. Now we calculated the R value. Now we'll calculate quality factor of the coil. So quality factor, Q factor equal to omega naught L by R. One formula is there. Another formula 1 by R square root of L by C. One more formula is 2 pi L F naught divided by R. This is another formula. Now we will use this formula. 2 into pi into the L value is 0.0507 into 10 to the power minus 3 into F naught, the 1 megahertz, 1 into 10 to the power 6 divided by R value is 30.8. What we calculated R value 30.8. So by simplifying this, what we got, Q factor equal to 10.34. So Q factor of the coil inductor is 10.34. So in this problem, we discussed the capacitor. The capacitor value is changed from 500 picofarad to 600. At the time, current become half of the value. In this, we got that Z equal to 2R. At resonance condition, only the resistance will be available. So that is nothing but Z equal to 2R. From that, we calculated the XL, XC value and R value. Finally, we calculated quality factor of the coil. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.